What's up, chemistry? Welcome back to the Dirt Bike Shed. We're going to finish up acids and bases today with a little lesson. Romeo is excited to be done with acids and bases, and we really did the entirety of acid and bases in 2 lessons, so I'm just cramming a bunch of stuff in there. So let's get at it. So in the first lesson we learned that the pH was the negative log of the molarity. Okay? Negative log of the molarity of an acid like hydrochloric acid, for example. So if you had 0.001 molar HCl, okay, then the pH of that would be 3, because the negative log of 0.001 is 3. Another way to write 0.001 is 1 times 10 to the negative third. And that number right there is the pH, okay? I realize that's small, it's up here, but this is just a super quick review. The pH scale we discussed last time goes from 0 to 14, so 7 is in the middle. Up here we can see this substance has a pH of 3. It would fall right here on the pH scale, right? 1, 2, 3, 4, 5, 6, 7, right? And then 8, 9, 10, 11, 12, 13, 14. Also, if something has a pH of 3, then the pOH is 11, because they both add up to the number 14, okay? All right, I'm done reviewing there. Now let's think about things that are acids over here on the left and things that are bases over here on the right. Here's a little pH scale. And you can see some of the substances on here. Something very acidic would be acid in your stomach. Then lemons, apples, tomatoes. There's milk. Here in the middle will be just pure drinking water with a pH of 7. Because it has an equal amount of free H's and OH's, right? And then as we go over here to the base, we go all the way over to ammonia, bleach, etc. Okay? Now, if you find something that's not obviously an acid or a base, let's say you find a clear liquid and you're not sure how acidic it is, you can use something called an indicator, like phenolphthalein. Phenolphthalein is a special chemical that changes colors when the acidity of it changes. Here's how phenolphthalein is spelled. Phenolphthalein is an indicator, and it turns pink in a base, and it's clear in an acid. So phenolphthalein, when it gets above the number 7, it turns pink. Isn't that neat? Now, there's not only one indicator, there are many indicators. Phenolphthalein is an indicator. There are chemicals in some plants around here like hydrangeas. Some plants may be one color in someone's yard and then another color in someone else's yard because the soil is different. There's a little thing I found about hydrangeas. They have blue flowers when the pH is below 5.5, purple when the pH is from 5.5 to 6.5, and pink when they're in higher or basic soil, right? So phenolphthalein is kind of like the hydrangeas. It's pink when the pH is high. Another famous indicator is something called bromothymol, and it is blue in neutral or base, and then it turns green when it's acidic. This is a very famous high school chemistry experiment where you take some bromothymol, put it in water, and you make the water blue, and then you just blow through a straw, and then the carbon dioxide from your breath changes the acidity of the water, and then bromothymol changes colors. So there are indicators everywhere. Probably the most famous indicator you're used to seeing is cabbage. Here is some cabbage juice. This is another thing I've liked to do in class. You take the cabbage and you just mush it up, right? And you know cabbage has purple and green and different colors in it. And then here is all the different colors that cabbage juice turns in these different pHs. So cabbage juice was a really good indicator that we used early in the study of pH. Now, we're going to talk about phenolphthalein for a second because it's a really famous indicator. I've got some, this isn't really 0.5 molar, but I've got some sodium hydroxide here. It's dissolved, and I'm going to set it on a white piece of paper so you can see it better. I'm going to take some phenolphthalein, the indicator, and we're going to test to see if this liquid is an acid or a base. Bam! See that? It is a base. That's what phenolphthalein does. It turns pink to let you know that something is a base. Now, on the right, I've got some hydrochloric acid. So you can see that it is clear, and I'm going to put some phenolphthalein in it. Oop. And notice it did not change colors. So not changing color is also a way that phenolphthalein indicates to us that something is an acid. So this is a base and this is an acid. Now, if you remember looking at the pH scale I just showed you, fruits, things like fruits, are acids. Acids are fruits. They're things that taste sour. Acids react strongly with metals. Okay? So I've got an orange here, and I'm going to prove to you that it is acidic. So I took this orange, and I squeezed some orange juice into this test tube. And we're going to test it with phenolphthalein, and I would ask you, is orange juice going to turn pink? Right? Phenolphthalein turns pink in a base, so is orange juice going to turn pink? Nope. Didn't turn pink, did it? Let's think of something else. All right, let's think about bases. What's the opposite of sour? It's not sweet, people. It's bitter. Bases taste bitter. Bases are found around your house in most cleaners. And in phenolphthalein, bases turn pink. So let's think about a cleaner I have. Boom. Got some Clorox, right? So you would imagine that was a base. So what if I sprayed this piece of paper here and then tried to drop a little phenolphthalein on it? What do you think would happen? Well, it's going to turn pink. Because that's what bases do. Phenolphthalein turns pink in a base. That's pretty cool, huh? All right, so now I'm back. I've got on the left, is this the base or the acid? You're right, that's the base. On the right, the clear one, that's the acid. So I'm going to flip them around, okay? And Mr. Perkins, why did you flip them around? I'll tell you why. Because 7 is in the middle, and now higher than 7, that's the base, right? And lower than 7, that's the acid. So these two line up with my little pH scale, don't they? Now what would happen if you had something that was acidic and you mixed it with something that was basic? You would pull them both towards the middle and make them both neutral, okay? So that would be called neutralizing. So I wonder if I can neutralize these two, okay? So here's my base. It's pretty strong. I'm going to be honest with you. I'm not sure I have enough acid, but we're going to try, okay? So I've got this pink solution. And as I pour the acid in it, I'm going to be pulling it closer to the number 7, okay? And when I hit the number 7, it will turn clear. Let's try. Let's pour a little bit of acid into this base. Just a little bit. Do a little bit at a time. See, it's trying to go clear. See that? We're getting closer, getting closer. Now what I did here was I neutralized it, okay? Now if I measured the exact amount of each that was needed, I could calculate, as long as I knew the pH of one, then I could calculate the pH of the other. And that's called titrating, okay? But we don't have time for that. So I had this base over here, and I pulled it towards the middle, and I also, I made right here, I made this solution neutral. I neutralized it. How do I know it's neutral? It just turned clear, okay? That's called neutralizing. Now, what is a fun thing to do sometimes is to see if we can get it turned back. Which one of these should I put in the water to try to get it to go back to the right again? Should I put the cleaner or the fruit? Yeah, you're right, I should put the cleaner. And if I have enough cleaner, maybe I can get it to go back. Okay, I'm going to try something a little bit different. Need some more, hang on. All right, so I'm trying to get it to go back. I'll let the foam settle down. We'll try a little. All right, there we go. So I'm adding the cleaner to it, and we're going back to the right again, correct? So now if I wanted to pull it back to the left, what do you think I could put in there? Well, I've got some acid here, and I've got an orange here. The orange, I don't know if I have enough orange juice to get her back, but we'll see. Yep, and putting the orange juice, it's acidic. Boom, I've neutralized it again, right? So we can go back and forth with things. So let's take a look at what a neutralization reaction is, because you're going to be surprised when you find out what's in there. When I mix this bleach and orange juice, I made something that is going to surprise you. What did I make? Yep, what I made was salt water. Salt water. Salt water. Mr. Perkins, you're a magician. Maybe, part-time on the weekends. But I wouldn't tell you, but seriously. Let me show you how you end up with salt water. When you neutralize an acid or a base and you bring them to 7, okay, you end up with salt water. Hang on, my dog is barking. Take a look at this. Hydrochloric acid plus sodium hydroxide, right? This is the acid, this is the base, yields, it's a double replacement reaction. So now we're going to have NaCl and HOH. Guess what? You just made salt water. That's crazy, huh? Now, neutralization reactions don't have to be that simple. They don't have to be hydrochloric acid and sodium hydroxide. We could do hydrofluoric acid and calcium hydroxide. Okay, we mix those two perfectly, right? We can end up with calcium fluoride, which is a salt. And then again over here we'd have water. And of course we'd have to balance it, but when you neutralize, when you mix an acid and a base, you end up with a, whoopsie, you end up with salt and water, okay? That's what neutralizing is. All right, I've got one more thing I want to show you here. Now, the rules for naming acids are really, really simple. If there is an oxygen in the formula, don't say hydro. That's it. If there's not an oxygen, say hydro. I'll do a couple and then I'll ask you a couple. HCl. See, there's no oxygen in there, so you say hydro. Hydrochloric acid. Okay? Now let's look at HClO3, which is also an acid. You see there's an O, so you don't say hydro. That's just chloric acid. Oh, excuse me, chloric acid. Okay? So this is hydrochloric acid, and this is just chloric acid. Okay? What about this next one? What about H3N? All right, H3N. Is there an O? No, so you say hydronitric acid. But what if we had HNO3? See, there's an O there. Since there's an O there, you don't say hydro. So that's just called nitric acid. Okay, now there's a couple of other little rules, but we're not going to cover them right now. I'm going to ask you 3 of these, and then you'll be done. Okay. What's the name of aqueous HI? You're right. Hydroiodic acid. Number 2. What's the name of H2CO3? You're right. Carbonic acid. Number 3. What's the name of HBr? That's right. Hydrobromic acid. Number 4. What's the name of HBrO3? That's right. Bromic acid. Let's do one more. And the last question, what is the name of H2SO4? You're right, sulfuric acid. We're done with our 2 acids and bases lessons. And peace out from the dirt bike shed.